Now, good morning, good afternoon, depending on where you are. Welcome. Today we are going to work on a authentication problem. So, the work has been explored a little while ago, actually a year ago, and responds to a problem that we have that was back then theoretical, but has become very, very practical, and that is that when a cluster is currently unavailable, today it's very hard, and in some cases impossible, to log in to perform queries and inspect the state of the cluster. And back then the issue was theoretical because the reality is that the root user can exploit the cluster generally. But even though that is true for the SQL interface, the web interface does not allow root to make queries. And in order for a user to perform debug queries through the HTTP interface, they need to log in, and the login mechanism for the web UI is not available to non-root users. It depends on system tables. And so system tables, if they are not available, will prevent the web interface from revealing data, and so will prevent troubleshooting in general. And so this RFC is making a proposal to introduce some caching so that some users become always available and can always issue queries through SQL and through the web interface. There are probably a couple of different steps involved here, and it's not so clear that we can do all of this work today, but I would like to spend some time exploring what's possible and what we should be looking at as a starting point, like a preliminary investigation, and see how far we get. This time slot will be bounded. We'll have a follow-up meeting afterwards. And we might have to recap a bit later. So the way we are going to do this, as usual, is to take the number here and have it introduced in our Tmux console. Like every time, I don't remember how to type this in, so we are going to copy paste this. Like this. Then we can paste the rest of the status line. This is very ghetto. As usual, I should actually have a script. But anyway, so here we are. Here's the link at the bottom of the screen. And we are going to start with a little to-do file. All right, so what's going on with this here? So we have two different avenues that use authentication. We have the SQL interface, and we have the web UI, which is now called the DB console. And so the SQL interface, how does this work? For logging in, it will query the system.users table, Actually, that might be sufficient actually to log in. Maybe others. And possibly system.namespace. And what we do have for the SQL interface is a special case for the root user. If there is TLS certificate, then the other authentication checks are bypassed. So I think that even though it would be nice to extend the mechanism for SQL so that other users and root can log in, we might already have a lot of the functionality in place. So I want to keep it in mind So what we might want to aim for is logging in for other users than the root user. The web UI, on the other hand, is a different kettle of fish. What it does really, it looks at system.web_sessions and it checks if there is a login token. So if a user comes to the web interface and doesn't have a token yet, of course the web session will not contain a token and then they will be left out. And if they want to take a token, they need to use a login interface, which will read system.users, perform some checks, then write to system.web_sessions. So obviously, if those system ranges are not available, the login endpoint is not going to succeed, obviously. Hi, mginov on the chat. And then the user will not be able to use the web endpoints. So what can we do about this? So there are some naive approaches, right? Well, naive and not so naive, actually. So possible approaches. So one thing we can do is TLS client assert authentication for web endpoints. And so, for example, same special case as SQL, valid root TLS cert means we can log in. So that would be one approach. Another way to approach this is, as recommended by the RFC, say we have a cache of credentials. And another thing we could be doing is perhaps a system command, maybe CLI tool, to generate a secret file on the server and create a way to use that secret to authenticate a HTTP request. So in terms of, so let's call them solutions A, B, and C. So when we look at securities, we are going to order them. So if we look at the different criteria, so solution A, B, and C. If we look at the criteria, then we can say, well, is it going to be resistant to man-in-the-middle attacks? Solution A, B, and C are fine. Is it going to be resistant to replay? Possibly. So with TLS encryption. And so here we are going to have plus server cert validation. Actually, that might be sufficient. So, nope. And then here, if we don't have any encryption, then nope. Partial. And then what do we have here? It's going to be nope. And then we have to replay attacks. So this is going to be no. Okay, sorry. But it's going to be here. no, yeah, partial, no. Why do we consider the TLS encryption case here? Is because we have a couple of situations where the administrator commands are run into a secure DMZ for a deployment that is not going to be secure with TLS necessarily. Now, arguably, of course, if one is in DMZs, then we don't really care about those attacks here. So I'm being a bit pedantic here, and we're not necessarily really talking about security. Now we're going to talk about resistance to mistakes here, like in particular, forget to disable the mechanism. So suppose we are inventing something to help with troubleshooting, and maybe the solution is meant to be disabled after it's not used anymore. So if the user forgets to disable the feature, is it bad for the cluster? And so the question to this here, it's going to depend. So here is going to be no, because the root certificate is not typically some things that people have in their hands. But I mean, that's the case. Second case, a cache of credential, no, because the user still needs to use regular credentials. But here we do have. Oh, okay, actually, okay, and here we have a problem. If we have a secret and the secret remains and so on, that's actually creating a potential security vulnerability that wasn't there before. So what do we have here? And that is the ability to get in even if the feature was not configured. So in the certificate case, that's okay. With a cache of credential, it will depend, and we're going to have an annotation below to explain why. And that is going to be okay with another star. Okay, so what are the stars here? Depends. That means only if the cache is enabled by default and has pre-populated. And then the OK star, that is only if the operator has access to the node. I think that already this analysis is showing us that we might need to do both what the RFC suggests, which is a cache of credentials, and also that file-based approach. So the reasoning I have here is that the mechanism for the cache is going to be dependent on whether the cache is enabled, whether it has populated entries already, but also it's going to be dependent on the mechanisms, the authentication mechanism being able to use a cache properly. So suppose there is a bug in implementation in a cache system that is much more likely to yield a problem where the thing doesn't work properly and doesn't get the access that's needed. And a file-based approach, in comparison, is much more lightweight. That is something that is much harder to get wrong, and therefore that is much more easy to rely on. So we might want to propose both things, and then if we do, then the question will come, how do we ensure that we don't encounter the problem when the mechanism is disabled? So we can mitigate the risk of forgetting about the mechanism by making the login token limited in time. And that means having a start time in the file. That indicates when it starts to be valid. And or maybe an end timestamp in the file as well. I don't exactly know what the best is, because that will make it possible to ensure that if the file is left over, since the server is not going to be accessed from the outside. I like this mechanism as well. Suppose that the file that is containing that token is stored in a directory that's controlled by Kubernetes as a secret store, like mounted as a secret volume, that makes it possible for an operator of Kubernetes to set this file, to enable this feature remotely from the Kubernetes management console. So I already have here some kind of intuition that we want to do the cache of credentials as recommended by the RFC, and also make this here as an intermediate solution for cases where the regular mechanism is not available. And so we're going to try this. And how do we do this? Well, we are going to explain all this in an issue, because there is no issue yet, and the RFC is not really an issue. So let's file an issue. Maybe there is one already, actually. Is there one already? Let's search for an issue. So, bug endpoint. Let's see. Maybe. Login times out when the cluster isn't in healthy states. That is promising. Okay, so that's related, but it's not exactly the issue we're looking for. Nevertheless, it really goes in this this direction here. So we are going to make some case about this here, and that is server create a way to use to access a cluster for troubleshooting when the cluster is not healthy. This encompasses okay. When a cluster is not healthy, we still want to access certain features, especially say debug endpoints under HTTP and possibly SQL. Today there is an escape hatch for SQL, which lets root log in by presenting /assert. However, HTTP requests cannot go through because of the reasons explained in, and then we're going to refer to this. Okay. Here's a range of possible approaches. And so we are going to explain what we have here. Extends the SQL escape hatch to HTTP so that valid TLS client source can issue HTTP requests. That's one option. Then we have create secret shared credentials. So API always via a file in directory or perhaps an RPC, so that's available via API's client cert. Or both. Creates a credential cache as discussed in. Okay. These three approaches seem complementary. Especially the third one is complementary to either of the first two. Okay, there's an enhancement, a security feature. Is there some authentication label? No, we don't have authentication as a label yet, but RPC, yeah. Cool. And now we have an issue number here, and that means that we are going to extend our status bar here to mention this new issue number we just filed. It is perhaps a bit loud in the mix. Yes, there is an auto ducking. I did configure that. Although if you do notice that the music gets too loud, I will welcome that feedback so that I can adjust the settings. Cool. Alright, so we have this issue now. I think that for today, it might be worth exploring those two things. No, that's not actually a thing. So I'm going to I just made an analysis of this here. So, regarding the first solution, TLS client certs, that is relatively unworkable because the HTTP-CA chain may be entirely unrelated to the RPC or SQL cert chain. That means that a TLS client cert valid for RPC SQL is likely not valid for HTTP. Making this better would require reworking the TLS configuration for HTTP to include the RPC CA, but that seems prone to errors and arguably dilutes the separation that is currently enforced by having separate. We are reducing overall security just for the benefit of an uncommon situation. So actually, the first idea that we just had was not super good. So we are going to cross it out. Cool. And that leaves us this. A shared secret credential known to the server, and that can be created using another credential that is Using one credential to enable another one? Oh well. I'm okay with this conceptually. Doesn't seem unreasonable. So then we can discuss whether we want to have the credential on disk with a file, where the mere presence of the file would be sufficient to create the escape hatch, or whether we want this to be in memory. So here we are here about, we're going to analyze this. So analyzing, say, design space. First, the second option, on-demand shared secret. So we can use solution A using an RAM-only secret. Set up via RPC. So then we are going to do a pro-con analysis. Am I forgetting anything? Thank you, Jordan, for the comment on the volume. I did reduce it a little bit. Speaking of reducing things, actually, I'm noticing that I'm not setting up the key display today. No, it is there. All right. So, solution 1. That is super easy. Small risk of credit leak. And then RPC, we have no risk. Less risk, actually. But still one risk because maybe there will be a man-in-the-middle approach. However, there needs a working RPC server. So if things related to RPCs are broken because network configuration or whatever, it's like if the user that is need access So in particular, the first point here, need access to RPC, is a tricky one because it's possible for an operator to have access to the Kubernetes commands to create the authentication file and have access to the HTTP port, but do not have access to the RPC port. So, no. Cool. So we have our analysis here. So as you can see, we started from virtually not much understanding of the situation, and bit by bit, by exploring the problem and the space of possible solutions, we are converging towards a possible approach for today. So I think that based on this analysis, we are going to try the file on disk approach as a starting point. Cool. Cool. So now, so we're going to have an analysis. So do we want this? We probably want to start with HTTP. Because we have another, so we don't use the same authentication code for HTTP and SQL, and so until we merge the authentication approaches, making this work with both HTTP and SQL require both two different code bases, if you will. And so for the sake of analysis, it may be worth as like a starting point to have it work with HTTP, have people discuss the ergonomics based on that approach, and then based on feedback decide what to do. Maybe we will regeneralize, maybe we'll take something else or go in a different direction. We'll see. Cool. So what do we do about this? Well, we are going probably to do test-driven development. That means we are going to set up a cluster, make the ranges unavailable, and then make a query and see what happens, really. If the problem is solved, then the query will succeed. If it is not solved, then the test will fail. And so we can write a test. So the unit tests we want will be something like start 3 nodes, wait for a replication, then stop 2 nodes, then use the HTTP interface on the nodes as left. And right now that is likely to fail. And so, well, if it fails, it fails. If we solve the problem, then this will succeed. So how do we do this? We are going to make a test. Admin test, I suppose. Going to be here. So test emergency authentication. Checks that the HTTP interface can still be made reachable via the emergency authentication mechanism, which is still to be determined. Even the majority of the cluster isn't available. Come on. Then we have some copy pasting of starting a cluster. Cool. Waiting for up replication. How does this work? There is a test I wrote in a different PR, which I'm going to copy paste the code from because I don't want to be writing this from scratch. So that would be this one. And so this is this here. Wait, are we in the right file? Oh, that's not going to. We can't probably. Can we use this test? Maybe we can. So 3 not ready. And then we can this Show ranges. Not ready. Cool. I wonder. Yeah, that seems to be fine. We need a context. Okay. Now we have okay. And now there's just one node remaining. And we are going to try to access the HTTP interface using the node remaining, which says 0. Let's try this. So how does this work? And authentication unauthorized. We probably want this one. So let's see how this is implemented. Okay, so there are two different situations. We have one situation where the authentication cookie does exist already, and the one that's where it doesn't. So we are going to test both. So what's the URL that we care about? URL. Ooh. Debug URL. Like this. Okay, so we're going to check the debug URL in a moment. Admin debug auth. Yeah, actually, that's an extension. All right. So what we want here is that this request fails today. So, okay, so we have two different tests. We have one test where the authentication cookie already existed before we stop the server, and another test where we do it afterwards. Let's see where this is happening here. So all right, that's interesting. So we may need to have one admin and another admin, and then root as well. So we're going to use this server interface because we want two users. Okay, so we're going to create an login token for user admin1. Create two admin users. Okay. So it's going to be this. Cool. And then that's going to be create user admin1. Okay. Why is this not succeeding? Oh, because I forgot to continue here. Alright, so we have S0. S0 is here. Okay. So 0 is the test server. HTTP client and session cookie. I don't know how to do this, but we are going to be client cookie get cookie for admin1. So admin1, true. Okay. I don't think we're going to use say admin1, and we're going to, before we do anything here, we're going to check that admin1 can do things. No, false, no. But just like sanity check. And so we are going to do this. And we need the URL. Come on. It's this one. Cool. Then we stop 2 or 3 nodes, and we are going to check that the request fails. Okay. Ensures that okay. And 1. And then try to, we expect the test to time out here. So this is going to be S0. That's going to be URL. Okay. That looks better. DC is the test cluster. DC. Okay. Sorry, try to use client 1. Let's try this. We are expecting this test to fail for now. And we'll see if that is the case. Yeah. We are going to make this a username, security. I don't remember the API for this. going to check it. SQL username from pre-normalized string. Oh. Oh. I mistakenly copy-pasted something here. Cool. So this test is going to last for a little while, so we probably want to have this. Okay, so I made a mistake in the syntax here. From show ranges. Force. This says that this query has invalid syntax. Not ready. Show ranges. Okay. Oh. Okay. So it's going to be show ranges replica. Oh, create user admin 1, admin 2. Interesting. So it's possible that the test cluster is already creating the user. Oh, look at this. Oh well. Alright, so I don't need to do this check because the facility in test server is already doing this for us. That's interesting. Okay. All right, so we are going to let this facility create that user for us. So we don't need to do this here. Create admin. And then we can try again. And I'm expecting a timeout, and it did not get a timeout. That is not good. That is not good at all. If the nodes are stopped, why does the request succeed? Oh, that is possible because the connection to the server is still open. Is that a thing? Is the HTTP client in Go able to reuse a server connection? That would be interesting to see. I don't think so, actually. Oh, does it? Remove empty ports. Host. Request. Get. Get. So that was a request. And then there's a do. Do. We are looking at to see here if the server is reused, like the connection to the server is being reused. Doesn't look like it. And then there's a send. So it adds a cookie. Send. Close body. Header. User. Set request. Round trip. Yeah, it seems that... Yeah... Yeah, I don't know. I don't know. Actually, I don't know. 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 This test should fail, and it does not fail. That's not good. Which means we might need to use the command line. Maybe debug URL first. Let's see, debug endpoint. Oh. Now. Handle landing. Is possible, not super certain, but it's possible that the debug endpoint does not the slash debug path does not require authentication. So we are going to verify this. So if I do curl ko actually, no, minus O. The valid authentication cookie is required. That is what I want, actually. That seems right. Alright. Well, we are going to create a multi-node cluster and see what happens with that. Cool. All right, all right, all right. Alternate cluster. Init. Okay. The cluster is there. Let's wait for replication. All right, now it's up replicated. Cool. Now we are going to say auth session login root. Oh, actually, let's create an admin user. One. Okay. Now I have a cookie. Let's copy paste all this. I can't copy paste. Aha. Server remote debugging mode is not allowed. I'll take that. I'm going to restart this node and say that HTTP add is only localhost. And then it's going to be localhost. Cool. Cool, cool, cool. So the debug endpoint seems to be at a different location, which confuses me, maybe? Is it not the place where it should be? It should be there. If I don't use the cookie, what do I get? I get a query that the cookie is necessary. And then I can do pprof. Okay, I like this. So here my command works. And if I stop 2 nodes out of 3, my command still works. That is surprising. It's supposed not to work. It is not supposed to work. I have a valid cookie, but the table is not working. Aha. I can't log in with SQL. That means that my cluster is indeed unavailable. So that is fine. Let's see, we want to have a debug. Yeah, so node build info is host because probably the system namespace command is host too. So we can't really, let's say select one. Yeah, okay, so we can actually send a command. So try this table. That is not working. Not working. Not working. Okay, so cluster is host, but I can still run. Oh, actually, the cookie validity here is not valid anymore after a little while. Oh, I have some idea about this. So let's restart those two nodes that were... okay. I know it works again. Oh, interesting. Okay. So there is some kind of timeout. There is a moment where we can't use the range anymore after a little while. So not immediately, just after a little while. That's interesting. Let's put some lights on this matter. Ta-da! Alright, so what's going on here? That seems that the authentication tokens, it's not that they're valid for a little while, it's like the ranges that is necessary to access the login token are valid for a little more. So this is valid for a little while, and then there is a moment where it's not valid anymore. So yeah, I think I understand this. Is because the first node is able to read the authentication data for as long as it holds a valid range lease on the web sessions table and the other tables. And so when that lease fails, like expires, that is where we stop being able to log in effectively. So what we need to do here is a basic test, is extend our test to expect a timeout. So that is not going to happen immediately. There is a short amount of time where the first node still has a valid lease on the first range and can read data from it. Wait until this has expired by waiting until the HTTP request actually reaches its timeout. We also want probably to use a new get context thing here, if that is a thing. No, it's not a thing. How do you set a timeout in the request? I don't remember how to do this. New request, I suppose. Oh, and then with context, I see. And then do. Okay. So we are going to say rec is client1 dot new request. Oh. That's going to be succeed soon. Okay. Cancel. Okay. I think that's the syntax. Right, this. I don't remember the syntax for this. And there is no body. Cool. Oh, what a good number. What is this music? We turned it on. Okay, is that the... method URL body. Here I actually wanted timeouts. So let's see what this says. Please cancel. Thanks. Succeeds soon. Cool. Okay. Okay. All right. So what do we have here? We have a test where after shutting down 2 out of 3 nodes, the admin user is encountering a timeout when they try to log in. And after this, we are also verifying that admin 2 is shut off from the cluster. And that is supposing that I wanted to get a login endpoint. I need need to have a password for admin2. How do we do this again? We need to have a... how does this work? If I want to have a login... a authentication endpoint, user login, it's authentication server. Authentication, and that is on SUS server. User login. Okay, we're going to try this. So that's s0.authentication.user login, and then we are going to have another CTX with timeout. And then server pp user login request. So what do we have in this? It's a username, admin2, password, ABC, and then RESP. I think we're expecting an error, so it's not going to be an actual error here, but I also want to see the exact nature of the error so that we can have a fine-grained condition. Did this test fail? Result is ambiguous, I suppose. Text deadline. Cool. All right. So this unit test here is showing us that a user is indeed logged out if the cluster isn't available from the HTTP endpoint, and that is not ideal. So that is a good unit test, and that's going to serve us as foundation for the MVP of the change we want to do in a second. All right. So it's been a little more than an hour, and so as those things go, it's important to take a break. And so I suggest that we take a few minutes to relax, hydrate, move around, and we can then reconvene in a few minutes. Let's say maybe at 10 to the hour, like in 3 or 4 minutes. All right. Enjoy your break and see you all in a few minutes. And we are back. All right. Hi everyone. So, cool. Now we have a server that refuses HTTP requests for users when some ranges are unavailable, and we want this to become possible. And we said maybe the existence of some file can allow us to bypass those checks. So, there are plenty of places to look at, but the real heart of the matter is where the check is happening. There are two different checks, and we need to bypass both of them. So where are they? So, one is in the authentication handler to detect the authentication cookie. So where is this happening? Something about the authentication endpoints. Authentication of the... I think it might be authentication here. The thing that checks the web session. Web sessions. Where is it? Verify session. Get session. Server HTTP. There we go. All right. So get session will look at the cookie inside the request, decode the cookie, then call verify session with a cookie, and then it gets a username from the cookie. That is to ensure the session can be open. That is the first check. And so we can have a bypass in this function here, verify session, which instead of looking at the table web sessions and get everything from there. Actually, why is this actually using the hash secret? That makes no sense whatsoever. Oh, it's because it verifies the cookies this way. Okay, well, I accept this. I accept this. I like what I'm seeing here. All right, so we can add something here. So suppose that we add something here whereby the session can be verified, and then we can log into user. So we are going to make a special case here and say return true admin 1 nil. What this does, it unconditionally accepts the session. So if this change is fine, what we'll get as a result is that even though the ranges are unavailable and the web session table is not available, this verify session will return true, and then the user can perform the query. And so, actually it should be admin 2 here. Suppose that this was sufficient, then the test here would fail. In the sense that admin 1, actually we want this. The admin 1 user will be able to use the debug endpoint immediately, and the query will never time out. And so we are going to verify this by adding some more verbose soon.go. Some verbose logging, because that is going to reveal something. So that's here. Succeed soon. That's going to reveal that even though this function is fine, there is another function that is not fine. So let's do this. vmodule soon is for. What's happening is that there are two checks in a row. One, that the cookie is fine, and the second check. I forgot the flag. A second check that the privileges of the user are sufficient to use the debug endpoint. And that is here what is not going to work fine. Oh, maybe it is actually sufficient. I'm getting confused. All right. I understand this. Okay, so I need to explain what's going on here. There are two layers of misunderstandings in this situation. All right. So my first idea was that the debug endpoints need both the cookie to be valid and the user to be an admin user. The second check we didn't bypass yet. And so I'm expecting the request to succeed the cookie check but fail the admin check and therefore get an error that the permissions are insufficient to access the endpoint. Nevertheless, however, what we see here is that the HTTP request is succeeding all the time. So my understanding of situation, the first one seems to be wrong. Now what is going on, and now I'm thinking about this just now, is that we are using, say, a debug URL defined here. And this debug endpoint actually does not validate permissions. If you look at this, so we're going to restart our multi-node cluster, and I'm going to make a case about this. So say I'm creating a non-admin user. Create a user non-admin. That's what I want. Right? And then auth session login, and then I use my new non-admin user. This is not an admin user. The cluster is operational, and the question is, can I use, say, debug endpoint? And the answer is, it depends on the URL that I choose. So if I say localhost/debug, with the cookie I have, which is non-admin, I need to disable TLS server certificate. It says admin privilege required. Oh, actually, I was mistaken. Triple misunderstanding. Admin privilege. Pre-prof, admin privilege required. Damn. Build my binary with a new bypass. Then we're going to restart 3 nodes. Right, so I start 2, 3 nodes. Not started. Now I stop this node. Well, actually, I want to start it. Let's do a new certificate, a new cookie. Then we are going to copy paste the new cookie in the command line. that gives us a check that it works. The user is not an admin user, and they are able to see profiles. It's not great. That is not great at all. This is not an admin user. And they can still use this thing. Ah. Why? Why? This is not good. This user is not an admin. Why are they able to use the pprof page? Let's see. Maybe some pages require admin privileges and some don't. Maybe. We are going to check this. Pprof CMD line. Yeah, that is not good. That is not good. I seem... Oh, what's going on? All right. Reset. Let's start a little bit behind. Let's start a little bit behind. SQL. Show users. I have admin 1 and it's part of the admin group. And then in the authentication server, I have verify session. Oh, now I understand. Okay. So regardless of the cookie that has passed, it's reporting admin 1 in the results. And that's why the debug endpoint is succeeding all the time. Okay, now I understand. So it doesn't matter which cookie I pass, because what's happening is that the cookie that I pass is overridden by the identity of user admin 1, which is an admin user. So that is actually what it's fine. So that's fine. Let's come back. Now we stop those two servers, which is going to eventually make some ranges unavailable. And so here we are going to continue pasting this command for a while. And what I'm expecting is that at some point the query should fail because the user is not an admin. Is that the case? It doesn't seem to be the case. Query seems to continue to succeed. Oh. Yes. I think I know why. Now we're going to stop the server and restart it. And now if we start this. Come on. Okay, so node starts the second node. There we go. So stop this node. The node is started. This node is stopped. Then we run this command and it hangs. Okay. So what's going on? The membership of admin 1 to the admin role is cached in memory already. So there is a cache for the role membership. That cache is not updated regularly. It's updated only when role membership on disk actually changes. That does mean so that after we sent a successful request for the admin role membership, then a success that comes in after the tables have become unavailable will still appear to be successful because a role membership has been updated and is cached. So in other words, in our test from earlier, here, this loop here will populate the role membership cache for admin 1, and then after it's populated, the moment the server becomes unavailable, then it's still there, and so it continues to succeed. It's not actually helping us immediately. So this part here is going to succeed, which is fine. But then this part here is going to fail. Okay. So we're going to expect a timeout. Then we're going to restart the first server. Is that going to work? Maybe not. We're going to restart. We want to have the role membership erased. How do we structure this test properly? We want to bypass the role membership cache, and then let's see, how is this being checked here? Require admin. Or admin user. Get user and role. Has admin role. Then we have the is root. Oh. So if there's a cookie for root, then we're not checking. Oh, CRDB internal is admin. Oh, that is why we are using the role membership table cache. I see. So there is a shortcut for is root user. Fantastic. Okay, so that is already a thing. So if we were to create a cookie for root, then we would be in the clear. All right, I think we have a strategy here. So we have a strategy. So we have here two special cases. Then system.role members if the user is not root. All right, so we don't need to care about system.role members if the user is root. So what we can do is create a login token for root and say that if the cookie that is passed is a root cookie, then we have a root login. All right, now we are talking. All right, so that's the check we need to have here. Okay. Okay. Here we have a business. So what we're going to do is have our special case at the start of this function here. So if have user there we go. And now we are going to have here a file-based authentication. Okay. And then we are going to have this into a new file. Come on. This. And the cookie is going to be, oops, is going to have a separate structure. Oh, cookie. It is a server PB session cookie. And so what does a session cookie look like? I don't remember. ID and secrets. Authentication. Key. What's the name? Session cookie. Here we are. From successful login requests. Maybe that's not verify session. We need to change. Let's see. Here. Decode session cookie. Decode string. Then we have a cookie here. All right. This is where we are going to have our Secrets. Oh, I like this. Oh, I like this. I like this. I like this. I like this. Yes, I know how to do this. Authentication, verified. Session. Okay. And then instead of checking all this, we're going to look it up. Look up session in C in RAM special session cache store. And so that's the thing. That's the thing. If has session username has special session that's what we had earlier actually. All right. All right. And so what we're going to have here is a authentication server, authentication server struct, and that is special sessions. All right. Okay. Okay. Here we have a map. That is a secret and a username. String actually. And then we have a map going from session IDs, which is going to be int64 to a special session. Probably like this. All right. And now we are going to look that up. sensitive access, maybe. Oops. Okay. Cool. All right. Special sessions. Do we want to check anything else? Probably an expiry. Maybe an expiry. We probably want to verify that we are not reusing a token beyond its expiry. So where's that? And we have a check here. S.server.cloud, no, where's that? Actually, I think we also don't want an error here. Maybe this function does not return any error, maybe. I'm not 100% sure, but it's possible. All right. Alrighty. So that gives us here a mechanism that if the cookie is in the special session map, the user will be able to log in. And now we want to populate a file, to load those entries from a file. And so how we're going to do this, we probably need or want to enter this from a similar format as the cookie value byte. So we are going to encode the session cookie. Actually, that's just this that we need. So CLI auth session, and we are going to have another login, logout, login, CMD. So this is going to be something like login, but it's not going to be login exactly. So create a shared secret token for the given operator is responsible for copying the token to the adequate login file on the server. Okay. So we are not creating an authentication token. We are just arbitrarily creating a key for a random server. So ID, that's going to be rand. I don't remember. How does rand work? Oh, like this. I don't understand why I don't get an int 64, I suppose. I don't know. I don't know why I can get a random. And then I need a secret. How do I generate a secret? I don't know, but we can probably use a UID. We have a UID functions. Generator UID.go. UID deterministic. No, I want to have a regular generator. New v4. Alright. HTTP cookie. Then I want to have this session cookie. How is it encoded again? Still the encoding? Oh. Actually, I just want those 3 rules here. So this cookie value bytes. Value. Go to string. Oh, the value I already have here. Oh, actually, I like. Okay, let's re-obtain this. So that's HTTP cookie. So we are going to have fmt.println entry for the special login file to add. You must add file. And now we are going to have a username. And then the ID. And then the HTTP cookie. And the UID, I suppose. All right. And then this. And then this. And then this. Cool. Let's build this. We have created here a command line utility that is able to generate a cookie for the command line user. Special login. I like this. I like this. This is actually what we need. Oh, that's going to be so great. So great. Okay. Now, it's been 1 hour again. So, time for a little break because we will be able to wrap up quickly after this. But nevertheless, it's important to move around. So, we will see each other again in a few minutes, a bit before 1:45. Now, enjoy your break and see you again in a few. we are back on stream. Here is the output, and I just realized that we are missing a timestamp. So, max time or expiry time. This and just print the example. And the thing that is missing from then on is the ability to load this data from file. And that is what we are going to define here. So this is like a dummy file name. And then we're also going to say contents. Is that a thing? Read all. No, that's not right. Read file. How do you read an entire file? IOUTIL. Read file. Okay. And then it's going to be string split at new line boundaries. And then it's going to be for line range line strings dot trim space line strings. Continues comment. are going to have the parts. And then we want to have 4 parts: username, ID, UID, timestamp. Then username, then UID, session ID. That is dir-conf parseInt64. I think it's going to be 10. Okay, then we have the UID. Parse, no. Oh, string bytes. Is there a conversion function here? Codec, maybe. From bytes, from string, like this. And then we have the nanos. Okay. And then expiry. From how does this work again? Using, if I want to start from nanoseconds. Unix. Okay. And now we are going to add this. New special login. There we go. Go, 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 go. Log tags, stack off, whatever. Oops. Can type. Other way around. Where's this? Alright. This builds. This function is not called anywhere. So now we need to call it. Load data from file. Cool. All right, so now we are going to place this data in the special file that we have just defined. Except that I probably want to have a new one. Non-admin. Let's start a server again, define the user. Oh, we did want to have admin, actually. Not non-admin. Oh. Right, let's stop the server again. Then we are going to make them log to standard error. See whether we see the special rule that we have. Did we see them? New special logging for admin1 secret blah blah expiry at some time. Okay, so it is getting loaded. And then start this node, start this node. Alright. And then we are like this. Wait, did we? Okay. Host. What's this? Debug. Valid authentication cookies required. So that did not succeed. Okay, well, there is probably more to investigate. Let's say we are on the right path. The path is to have this registry in RAM of pre-loaded authentication cookies and have the authentication code read from that data structure. Except that this is not complete yet. It's not working yet, and we have a time limit. And so I'm going to stop the work for today, and we are going to commit those changes as intermediate steps. We need a branch. And then commit this, work in progress. And that commit message will be enhanced later. And so this way we can resume the work a bit later. Cool. Now, thank you for watching, and hopefully we will pick up this approach in a later iteration. Either I will do a bit off stream, or another possibility is that we will just continue this on the next stream. Now, thank you for watching. Thank you for your attention, and see you all soon. Have a great day.